Alrighty, so how many of you know what Kubernetes is? What Kubernetes is?
I
Moderately.
couldn't describe it. I wouldn't be able to describe it to you.
Okay,
That's what I've heard.
I kind of know what it
Okay.
is. Yeah.
go for it.
It's like orchestration, right? So it'll allow you to set up and, like servers and all that kind of thing for your application.
So it's a Stravinsky guy with a wand.
That's how I interpret it.
Okay, now
It's Swarm only better.
what's that, Jared?
It's like Swarm only better.
Okay, and what is Swarm?
Yeah, that's a good question.
Okay,
Nice.
so the descriptions are good. Kubernetes, to the best of my knowledge, the way you would describe it is an orchestration framework. It allows you to orchestrate containerized applications and schedule containers coming in and out of existence, as well as scaling and many other things. And the bottom line of this is we're doing this to replace effectively what we're getting from Heroku or what we're getting from AWS and Elastic Beanstalk. So I'm borrowing these slides from Lan Chan, which is the main architect who's spearheading this effort, and the engineering productivity team. So it's a little bit of my slides, a little bit of them. So this is kind of a summary so we all get on the same page, and then we're going to do a little demo of how we implemented our first proof of concept on the bump for one app. So why are we doing this? An ecosystem that is developer friendly. Any of you have any experience with Elastic Beanstalk? And you guys notice that sometimes it can be a little painful. Sometimes you don't know what's going on with the deployment. Sometimes it can just get stuck. Sometimes it's a lot of a big black box. With Kubernetes, because it's an open source thing and because we are doing the tooling ourselves in the company, then we have control over all of these things and we're removing a lot of that pain. Also an ecosystem that is operator friendly, which just goes in line of that. Of course, a system that is fault tolerant because we intend to eventually have this in production. Right now we're doing it on QA just to get everybody acquainted, knock out all the kinks and so on and so forth. A system that scales to demand, meaning that, and also that is cost effective, so meaning that if we need to provision more and scale according to our needs and according to our traffic, it is in line with what we want. It is in line, it is cost effective. I get lost in words, so I apologize for that. Also, a well-monitored system out of the box. We all have been through the journey in which we want to have monitoring for a system, and it keeps being like a layered cake that every so often we need to add a new thing and a new thing and a new thing. If it's not NodePing, it's New Relic. If it's not New Relic, it's Honey Badger. If it's not Honey Badger, it's Sumo Logic and this and that. And what we found is that there's a lot of disparity between all of these systems from team to team. There's a lack of consistency, and that takes time. It increases the time to onboarding. So a little bit of the idea behind this effort is also to standardize all of this so that you can very quickly and very easily provision an application and have all of this stuff out of the box. Then a system that is portable, this is very important because now we're kind of married to AWS, but in the future, if we want to use another cloud provider like Google or even Azure or something else, the way this is architected, we could port to that other system. There's a very weird edge case of a company that was doing business with Walmart, and because they had everything in Amazon and AWS, Walmart specifically put in their contract that they wanted them not to use AWS as a provider because Amazon is a competition of Walmart. I don't think we're going to get in there, but it's kind of a silly example. And also a system that is well documented. Okay, so let's look a little bit at the terminology of Kubernetes. So first of all, container, most of you are now familiarized with what it is. It's the minimum, container is something that hosts an image created with Docker or some other system. And in our case, it's Docker, and it's usually the minimum expression of an application needed to run, which encompasses the operating system and the application itself. In the case of Kubernetes, it could be a container or it could be a collection of containers. I mean, an application can be several containers wide, because you can have one container for the application and another container that can be used for login and another container used for some other service. Next thing, what is a pod is a little bit an extension of what I was saying. It's a logical group of containers. So your application might be just a simple bare bones Ruby application and it only requires one container, and that's fine. Then your pod will only have one container. But like I said, if you have something that is the application and then you got another container that is the logging, some standardized logging system that we're using, and then another container that is doing something else, then this logical group of containers that comprise your application is called a pod in the Kubernetes terminology. So the next thing that happens is a deployment. A deployment is the abstraction layer placed onto the whole replication of all your pods. So the pods. So if your pod spans 3 or 4 instances for scaling purposes, then that is called a deployment. If it's only one instance, one pod, then it's a one pod deployment. Okay? Then a service is, the abstraction layer on top of the group of containers that take in incoming traffic. So in our case, where we have containers for an application and a container for logging, and we have it spanned out over 3 instances, 3 pods, our load balancer is only routing traffic to the application. So that is what comprises the service in itself. It's another abstraction layer related more to the HTTP traffic. Then ingress is essentially how you define what traffic gets routed to the service. I'll talk a little. This will become a little bit clear a little bit later when I show the examples. Then this is more of an abstraction of how the whole machines, all of the machines that comprise the Kubernetes cluster look like. So this is a worker node. It is one of several machines that host all of our containers. So it is like a very big AWS EC2 instance, and this will host our containers. Then we got something that's called a master node, and what is in charge of doing is scheduling and coordinating which applications go to which container. So a typical topology of a cluster looks like this. You got several master nodes that are redundant, so if one goes down, then the other ones take over, and then a ton of, what are they called? Worker nodes, thank you. Worker nodes that, there it is. And then the worker nodes that host all of our containers. And this is designed to be redundant and fault tolerant, and that's as much as I know.
So, question.
Yes.
Where in this is what's represented by a pod here? Where can I see a pod?
That's a good question. So pods are not represented here, but typically it would be, that's up to the scheduler to define it, but for instance, if the pod is like 3 of these little containers, then the master nodes know about it. They present it to you when you interface with it as a pod, but internally they know which containers belong to this pod within all of these containers. It's abstracted from you, and that's as much as I know. But, yeah. Okay, so resource allocation. So typically, there is a scheduler that you tell it, hey, can you please deploy these applications to to so many pods and so much scaling with so much resources, and it'll take care of deploying the images to the containers and spinning them up. Routing shortcuts, for the purpose of this session, I'm just going to mention that there's 2 routings that you can define for the cluster. You can define a public routing that also can implement TLS, in other words, HTTPS. That is typically for the public incoming traffic. And then there's an internal routing, which is a little bit faster. That you can define. And there's some conventions that you're trying to use, like Service Identity API, QA, local partners, tk.com, I gotta find out a little bit more about the standard they want to use for naming the routes, but it's something of this nature. Not gonna talk about this particular thing. Let's talk about the tooling. Okay, so engineering productivity has been writing these tools to simplify the whole implementation and usage of Kubernetes, and they are mainly ExoHelm, and there's links to the repos at the end of the presentation. We got ExoHelm pre-prod, which is going to be used for QA, and ExoHelm prod. That is basically a tool that has a summary of all the commands that you need to administer a Kubernetes deployment. Then there's Helm, Kubectl, and Docker. For the purpose of this presentation, you don't need to worry about Helm and Kubectl because those things are kind of abstracted away into ExoHelm. Docker, you need it because if you don't have anything Dockerized, then none of this makes sense. And then there's things that are called Helm packages that are, think of them as configuration files that are passed on as a parameter to ExoHelm that summarize what kind of application you're going to be deploying. If it's something like an API or a web server, you're going to be using Exo App Manifest. Excuse me. And if it's something like scheduled task, worker, or something that runs scheduled jobs, you're going to use Exo cron job manifests. In this presentation, we're only going to go at we're going to only look at Exo App Manifest. We can do a follow-up on Exo cron job manifest once I learn how it works. All right, so any questions so far?
This might be jumping ahead, but if you have sort of different types of pods that you're deploying, like you have a bunch of applications and then a database, are those, like, is that part of the, I guess, what level do you define these are the things that make up the different pods that make up an application?
You mean how do you name what?
Like how do you say, okay, I need 3 pods of this type and 1 pod of this type, and this is how they interact with each other?
So let's say you have an API and then you have, I don't know, some little service that does some math, whatever. Those are separate applications. The question is, how do you decide to manage which application? Or how do they interact between themselves? What is it?
How do you get them interacting with each other?
How do they route a request between each other? Well, each one of them is going to have you're going to be defining an ingress in here. Let me just go to the part where we say ingress. Okay, so you're going to have an ingress. You're going to say this application is going to respond to this URL, to requests that have this URL in them. You're going to be defining a CNAME or a URL. The load balancer is going to know that it has to route any incoming traffic to the cluster to that application. That's how you address the application from outside. Internally, we're supposed to use this private one, so I assume, I haven't gone into the use case you mentioned, but it's a good question, but I assume, and we can follow up with engineering productivity, that they would be addressing themselves with this internal private one. So if in the same cluster you have, I don't know, a web server and you have an API, then they would be addressing each other via this URL, the private one. But again, TBD, it's, go ahead, Piper.
And does that happen in something kind of like a Docker Compose file, but for Kubernetes, or is there an equivalent?
The way it's implemented internally, I don't know exactly. What you need to know is that you have one pod deployed, and then you have another pod deployed, and you have to configure how which URLs they have to hit to communicate with each other, just like you would do in Heroku. Go ahead.
I guess what I'm asking is, is there a specific kind of file that has a name that people talk about that is the configuration file?
Yes, I'm going to be showing that in a few slides. It's a good question. Maybe the slides answer them, or maybe not, so we'll find out. So any other questions?
I
I'll wait for the work.
Okay. Okay, so what would the typical workflow look like when we are developing with a continuous integration environment? So we've got to implement the method yay. So we add the code changes, we commit it to the repository, pull requests, blah, 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 all nice. Our continuous integration environment needs to do the following. It's going to pull the changes and any change, and by pulling that repository, it might also pull in any changes to the Docker file that creates the image. Then it's going to build the image of the application and run the specs against that container, because we gotta, and this is very important, not everybody understands this assumption to be true. The continuous integration environment needs to run the test against the container, needs to think as a Dockerized application, a Dockerized host, as a Docker host. It's important that we don't implement something that pulls the repository and then within the own implementation of the continuous integration environment, like Circle, that does it out of the box, run the Ruby specs or the node or whatever. It has to do it within the container. So hopefully that means that you build your application to be completely Dockerized, from the testing to the deployment and building and tagging and so on. So it runs the specs. If we get a yay, then what we're going to do is we're going to tag this image, and I'm going to show that in a few slides below, and I'm going to push this to Docker Hub. So what is Docker Hub? Does anybody know what Docker Hub is? David?
It's like GitHub for your Docker images.
That's what it is. It's an image repository. In AWS, we were using ECR, I think it was called.
Yeah.
Elastic Container Repository or something like that. So right now we're gonna push the image, we're gonna tag that image with a tag. I'm gonna show how it goes in a few slides, and we're gonna push it to Docker Hub. And then the next thing we're gonna do is send a command to the scheduler to say, hey, I got this deployment, I need you to pull this tag from this image, and then you're going to build it and deploy it to the deployment. Provision the containers needed with the images that I defined, and scale it if needed, and then start accepting traffic. And then traffic will start coming in, and hopefully we're all happy. Go ahead, Robbie.
So all the app manifests and the pod manifest, if there are any, they are on the cluster? Or
No.
they are part of the source code?
They're part of the source code, actually. So when you deploy, when you give the scheduler the order to deploy, the way it's set up, you pass in a ton of parameters that are part of these config files, and then those get copied over to the cluster in a part that I don't know where it is, but it gets copied there, and the cluster then knows what to do. You're basically telling it, this deployment has these image files with these tags, it has so many resources for memory and CPU, it has these labels, and it has these environment variables. It's almost the same as how you do it in Heroku, that you can actually go into a dashboard and you see the environment variables and the dynos and all of that.
Yeah, but none of those are actually, as of now, for instance, environment variables and the settings tagged in a Heroku app, they are not part of the application. They can be, but they are not.
Yeah, that's true.
And so basically, to me, they appear as an XML or a dictionary or a manifest, which can be part of the app or something remotely on the cluster. And so that's what I was actually trying to understand.
So the following slides, and when we do the demo, hopefully they're going to answer that question, but it's a good question. Okay, any questions on this process?
Can you also,
Yeah.
I forgot, what is a pod?
A pod is a logical abstraction of containers that comprise an app. So let's go back to it. That's a pod. Pod is the minimum expression of the app, of the containers that comprise an app.
So an API and a database.
could be, but I'm going to make a parent. For now, we're not Dockerizing or doing databases with this. That's for a future iteration. And the reason for that is, for now, containers are considered ephemeral. So if you were to Dockerize a database, you would only Dockerize the service part, but the persistence would have to be
But actually,
an actual database. For now, the plan is to use the database services that we have at our disposal with Amazon, like relational database service. But in the future plan, we will start implementing containerized databases. I wouldn't say that the database itself would be part of that. Maybe it would be, because that would be a separate service. In this case, I think the best example is the Logger application, because it's a standardized container that's in charge of capturing logs and sending them to a log aggregator.
Would like caching and Elasticsearch, like those type of services, would they also be inside of a pod, or would you consider that something different as well?
I would consider them as different, but perhaps there's something in between too. But for me, I would consider them different.
Yeah, I think anything that is going to scale independently of like your application servers has to be either a separate pod or separate something outside of Kubernetes.
Any other questions? Okay. Good. If you're asking questions, it means that what I'm saying makes some sense. Okay, so to be able to use all this deliciousness, you're going to have to do some setups. So first of all, we're going to have to be set up with a Docker Hub account. If you don't already have this, you're going to have to get it set up. And it's very easily just ask engineering productivity, and they'll set up a Docker Hub account. I'm going to show you guys what it looks like in a few slides. The next thing is, in the cluster, we are subdividing teams in what are called namespaces. So Baby Tech has one, Local has another one. I'm sure that TK Content will have its own. And that's kind of the way we're separating teams into this grouping. And the third thing we're going to have to do is we're going to have to tell Kubernetes how to communicate with Docker Hub to be able to pull images. There is some authentication that Kubernetes needs to do against the hub to get the images, so we're going to have to add those to the Docker Hub. That's one thing. And then as far as the project, the way we are routing requests from public requests are through Cloudflare. So we're going to have to create a CNAME within your domain and then tell it to route to the IP that we have set up for the cluster. We currently have two clusters. One that is called Thor, that is the QA one. It's also called pre-prod. And another one that's called Hulk, that is production. It's still not up. It's still they're still putting them together, but basically those are going to be our two clusters. So let's say we have a new application that's called Water Chocolate. So we're going to have Water Chocolate QA and Water Chocolate Production. We're going to have to create two CNAMEs in Cloudflare. One which is going to be prepended with QA, the other one which is going to be Water Chocolate by itself, and each one of those is going to be pointing to Thor or Hulk, respectively. Okay, any questions so far?
and I imagine these Thor and Hulk will have some sort of a routing with specific application.
Right, so the cluster has a whole load balancer and routing thing inside. When you're deploying the app, you're telling it what it has to listen to and where it has to route it to. So that's how this is all abstracted away. You don't have to worry about it. You just have to, in Cloudflare, point that CNAME to the cluster, and then the cluster will know what to do. Okay. Okay, so before I go into this, let's take a look at let's take a look at an application that I have set up here. So were you guys able to look at the avatars API application or the Git repo. Okay. So right now I have it. Sorry. So this is a very simple Ruby application that's built with a framework that's called Grape. It predates me. I don't know. We never used that framework, but it was simple enough that it was a good use case because it only interacts with the database and it has like 2 endpoints. So we have a health endpoint on the application, and right now we have it provisioned in Heroku, and also I have it provisioned into the K8 cluster. So let's start looking a little bit at how this is routing. Let's take a look at Cloudflare first. I'm supposed to log in. Okay, so in the pub.com, I look at my DNS and I look for avatars. So QA avatars API, which is the one I created, is an alias of preprod public USC CLB clusters xogrp.com. So here I set up the URL that we have for the preprod cluster that's going into Kubernetes. So now let's take a look at, hold on a second, I'm just organizing this. Okay, that's as far as the routing goes. Now let's look a little bit at the code of the application in question. So right now we have a make file that is summarizing all of the scripts that we are doing with Kubernetes. We have scripts for building the image, for running the test, for pushing it, and for tagging it. So let's say I just committed something and I go and do make build. This is going to build my image and so forth. It's going to take some time. So that built my image. Okay, while that image is building, let me guys show you what the Kubernetes dashboard looks like. Sorry if I'm jumping a little bit back and forth. I'm trying to optimize time here. So the dashboard is located here. I'm gonna paste that into bump content into. Do we have a super squad room in Slack?
We did. I think we did. I think Marco created one.
Okay.
There's one called Super Squad.
Okay, so I'm gonna put it in super squad. Supers. Okay, so that's the floor cluster. So you access it, you're gonna notice that here where it says cluster, there's a bunch of namespaces. Let me take a step back. This dashboard is basically our entry point of how we administer all of our Kubernetes deployments. It's akin to the dashboard you have in Heroku or the one you have in AWS. So in this case, I have for the bump namespace that was created, that was called BabyTech. Remember a few slides ago that one of the requirements was to have a namespace created for you. In this case, we have one that's called BabyTech. So now we're in this namespace. And in here, I can see the deployments I have under BabyTech. Oh, nice, it shows nothing. Oh, that's not good. Okay. In the right one. Even, oh, because it says default, it has to be here. There. Okay. So if I go into deployments, there's currently 2 deployments, the Avatars API one and another one is called Tiller, I don't know who that is. So we're gonna be, this is where our application, the sample application is deployed right now. If you go into pods, it lists both pods. If I click on it, it shows me metrics for CPU usage and memory usage. And I can also look at the logs. So you notice there's 3 of these here. If I call that again, you're gonna see that this added another one to the log. So that kind of is demonstrated on that endpoint is hitting that deployment right there. The other thing we have is an account on Docker Hub. This is what Docker Hub looks like. So if you go into the EXO group organization, this is where all the teams are putting their images. So if I look for avatars, notice we have 2 different repositories, one for QA and one for production. And the reason for that is because it makes administering the tagging more efficient, because you just have to tag. You don't have to be including the environment in the tagging, but you can change that. For now, we're doing it in 2 different repositories. So if you go into this one, you're going to notice then if you go into tags that you got all the tags that we generated for each one of the iterations of the repository. So let's do the following. I'm going to go and I'm going to make a small change into the code itself. I'm going to change the URL that I'm using for calling the health endpoint, and I'm going to deploy it to the Kubernetes cluster and show you how we do that. So let me go. This is basically where you tell it where the. Are you guys able to see, or is that a little too small? Okay, so how do I zoom it up? Does anybody know how to zoom it up?
Possible.
Plus,
No, I just use the trackpad. Is that better? Okay, so I'm going to change this to healthy. I'm going to branch out. Wait. So if I build this one, and then run it, I should run it on a local server. I should be able to access healthy instead of health. So we're just going to double check that. I think there's a more efficient way of building the images without having to do the bundling all the time. Jared, I think, researched a little bit of that. So maybe something worth looking into. Okay. Let me just move this up here. Move. So I'm going to do make run, and what make run does is it creates a Docker compose and runs the server just for me to test it locally. A few seconds, we have to go up. Okay, so I got a server up going locally. I do localhost healthy. There it is. Instead of that's running on a local host on the Docker compose. So that means that my container has the changes in. Okay, so let's stop that compose process. I got the image built. The next thing I'm going to do is I'm going to tag the image, and then I'm going to push it to the Docker hub. This is what the CI would be doing, but I'm going to be doing it locally. So I'm going to do make tag Let's expand this a little bit. Does anybody know how to zoom the shell?
Try Command plus.
Command plus. Awesome. Okay. So make tag. So what that did is it run. Let's look at what the Docker images look like. So I just tagged the EXO group. What I did is I grabbed the image that was originally built that was TB Avatars API QA latest, and I tagged it with this. EXO group, QA Avatars API, devom.com, and as a tag, I'm using the latest git commit. What that gives me is like a unique tagging of each one of the versions of my repository that it can then be referenced in the deploy. And it allows me to manage different versions that I'm deploying with a unique number. This is the practice that we're encouraging to do, to use tagging. If it's not the latest git commit, use some UID, but I think that the git commit is the best reference you can have because it's exactly the point in time of the code that you are referencing. So what that, you guys know how Docker tag works, right? So I don't need to go into the details of how that is implemented. It's just a simple Docker tagging. I'm just showing what I'm using. Okay. The next thing I'm going to do is I'm going to push it to the Docker Hub. I already have it all abstracted in. Let me just source this file that has my environment variables. Oops. Sorry. Got that. Okay. So make push. What I'm doing here is pushing. If you guys take a look at the screen, it's pushing to the Docker Hub, the latest, that version of the image with that tag. So if you look at this tag here, it's 795D blah blah blah. If I go to Docker Hub and I refresh, it's right here a few seconds ago. So now I know I have it up there in the Docker Hub repository. It's that latest version of the image that was tagged with this tag name, and it's up there. So now if I tell Kubernetes to go pick it up, Kubernetes will know what to do. Okay. Just for those that are not familiarized with the push command, it's basically looks like this. Oops. What is the command? No, it's this. So I'm basically logging into the repository and passing in the environment variables my credentials, and then I'm pushing the tagged image that I'm also passing as an environment variable. And I'm building all of that in my make file, so I don't have to worry about scripting it all. It's already all extracted into the make file. Okay? Okay, so the next thing we're going to do, we got the image pushed, we got to now tell Kubernetes to go get that image and deploy it. So the way we do this is by running this command here, that's exo helm, and we're passing the exo manifest as a parameter. So what we're going to be doing is we're going to be running this from a doc. The engineering productivity already put all of the Helm installation into a Docker image. So all you got to do is pull that image, run this command, and it's going to pull that image automatically, and you don't have to worry about anything. So let's look a little bit about what this is going to have. We're telling it, okay, on this Helm for the pre-production cluster, which I am parameterizing it with an environment variable, run this command, upsert the avatars API QA in this case, use this template, the exo app manifest. Remember there were two, one for exo app and one for exo cron jobs. This tells it that you're going to deploy something that's going to be an application that accepts HTTP requests. And then here's where you configure all of the stuff that's going to go into that deployment. Replica count is related to how many replicas we're going to have. how many pods you're going to have in your deployment. The image repository and the tag, these are two very important. You're telling it to grab, in this case we have it configured so it grabs what we have here, exogroup, blah blah, avatars API, thebump.com, and the tag in the make file, it knows to grab the latest git commit. So we're passing that as the environment variable in here in the tag. Then we're specifying the port that is going to be using. And then comes a series of labels that we have to, that are mandatory. Here we're saying the environment, stacks like the bump, what's the role of this thing, web, and the application name. It's the same thing we were doing with AWS and ECS, and it's very important to set these right because then we can run different auditings and say, okay, what team is using how many of what environment and this and that, and that way we can manage deployments better. Then we're going to tell these two here that are called ingress enabled and ingress hosts. Ingress enabled essentially says this thing is going to be taking in traffic from outside. And the hosts, which is the question I think you were doing, Ravi, and you were doing, Kyle, where is it getting traffic from? So in here, you notice this ingress host variable. I'm saying any traffic that comes from avatars API, thebump.com, is going to be rerouted to this deployment. And that's how I define it. The next set of things that we're going to be doing is we're going to be defining the environment variables that this deployment is going to be using. So in this case, I have rackenv that is used by Ruby and Grape, the Postgres credentials, the port that it's going to be using, and something that I need is the media API key and the media API secrets. So in this example, I'm passing all of these as I'm sourcing the environment variables. In the case of CI, you would have them configured in the CI configuration for that deployment. In this case, I have them sourced, and then they're being passed when I run this script. Then this series of commands tells it what resources you need as far as CPU and memory. I'm not going to go in much detail on this for now, leave them at that, then on your own you can research these. And finally, this part is very important, the image pull secrets. What this is, when you are in the cluster, you have, for the namespace, you have a section where you're defining the secrets that the cluster, the secrets for the Docker Hub, so that the cluster has credentials to be able to authenticate against the Docker Hub and bring in the image. So if you notice the name I have here, Docker Baby Tech CI, that is the same name I have here, defining Kubernetes and secrets, Docker Baby Tech CI, and here is basically, I set up the secrets that I need for my Docker Hub account. So that's how you're defining it. Use these secrets to pull these images. And finally, we're telling it what namespace we need. So this is a thing you just have to do once. Once you get it set up, you're barely going to be changing this unless you're changing some environment variable or some scaling or whatnot. Okay, so let's go ahead and see how this goes, how this works. All right, so I'm going to do make deploy, and that's going to run this command automatically.
Will those credentials come from Docker Hub?
Yes, so
And you just paste that in Kubernetes.
yes, and then you assign a name to those credentials. Okay, so let's look at our pods, and we're going to notice now that there's a new one there. Before there were 3, now there's 2. If I refresh, it's gonna, in a few seconds, gonna start scheduling in the new container. I wish there was something that showed this like in real time. You don't have to refresh. But anyway, it hasn't deployed yet. Okay, it should be running. If you notice, it says here 32 seconds. So if I go to my URL that said health, this should error out. It's a 404. if I go healthy, which is the change I just did, there it is. And if we go into the logs of this guy, this one, is that the logs? Yeah, those, no, oops, sorry. The pods. So there's one entry there. If I do this again, I should be seeing 2 entries. There it is. Okay, any questions so far? Okay, so we just saw the anatomy of the ExoHelm script and ExoApp manifest. You got it there in the scripts. So let's look a little bit at monitoring and debugging. Oops.
One question is,
Yes,
how should we hook up Dr. Hub with organization?
what do you mean?
Our personal Dr. Hub, like as the kind of Kubernetes group meeting, but I don't know that just the organization's abilities.
You need to ask engineering productivity. They're going to associate your account to, you know, actually I don't recall if, no, actually I'm signed in as Baby Tech. You see there?
Oh, okay, so I have to, is that the password state for something?
Yeah, so your particular team needs to have an account in Docker Hub. Actually, I don't recall, so there definitely has to be one for the team, which is going to be used for the deployments, the CI, but then I think that you should be able to log in individually and be added to an organization, and that's how you can see it. The images and so on and so forth. But ask engineering productivity just in case, because I don't recall the details. So, a few more things. Let's say I want to monitor, I want to look at the logs, but from more of a command perspective. So I have already abstracted in, sorry, my, I do it like that? Yeah, okay. The way you can do this with the command line is you first need to know what pods you have running, what pods you have, and then reference a pod by the ID that Kubernetes gives you to be able to access the logs or to SSH into an instance. So let's do the following. If I do make get pods, you can later look into what this make file is doing. So here it's showing me 2 pods. It's that tiller deploy that I don't know what it is, and this name here that it just assigned to my recently created thing. So then if I say make logs pod equals that name there, let me expand that so it's, there it's retrieving the last logs. It could be made better so it's tailing them, but for now I have it like that. You guys can expand it. So under the same thing, if I want to SSH into one of the containers, let's say my replica, my deployment only has 1 replica of a pod. First I do make get pods. That gets me, that's calling the cluster, say, hey, get me all of the pods for this avatars API. And I don't know why it's taking so long. Houston. Okay, there it is. So now that I have the pod name, then I can say make SSH pod equals this. And now I'm SSHing into the actual running instance in Kubernetes. So if I go LSLA, I'm going to see the actual, the actual application directory that I defined in my image. If I actually cat that change there, API RB, I'm going to see what I just did. Here's the change I just did. You can even cat, on there. I'm looking at the log file. It's everything you would expect from an SSH session. And then you exit, and it's right there. Now, let's say I want to roll back to a previous to a previous version of my to a previous commit. Okay, so because I tagged the images with the git commit, I could very easily just go to my, either I list the tags with a git command or I just look at my Docker hub and I grab the tag that was done before, right? So this is the tag. I'm going to do this. Make deploy tag equals that. And what I'm telling it is, okay, go ahead and do a deploy, but instead of pulling the image with that tag, just pull with this specific tag. And then the schedulers should follow through. Did that work? I hope so. Let's see. Should see now. So this is the one it just created. So it's unscheduling this one, scheduling this one in. We'll wait a few seconds. Yeah.
Is there a way to add new books before this?
That's a great question. I don't know. I guess you can ask. I'm sure it can be implemented into the packages because we own them. But also in the CI, Circle gives you options of what to do after a deploy. So maybe that would be the better place. You mean like reporting, like for instance, a New Relic deployment marker or things like that?
Yeah, or changing the environment variable or something like that.
Okay, environment variable, give me a second, I'll tell about that. So let's now go to the endpoint, and this is going to 404 because if you guys recall, we actually changed it back to health. So if I go to health, now it gets me to 101, and that's the previous version of it. So to answer your question about environment variables, if you need to change an environment variable, the best practice is to actually change it here, whichever implementation you have. In this case, what I'm doing is I have the environment variable sourced in this file that I'm not adding to the repository. This is local in my computer. So these are not in the repository. These would be added to the continuous integration environment under the secrets or the environment section. I don't remember where it is. So in any case, if you need to add or change an environment variable, it would be through these mechanisms. If you have to add or modify the name, you would do it here. And if you're changing the variable, whichever sourcing you're using to source that variable, you would have to do it here and then deploy. Now, there has to be also a better way of doing that now that I'm thinking, because sometimes in Heroku, we just want to switch on or off a variable, and this seems a little bit more convoluted. That's actually a good follow-up question to do. But initially, it would imply going through this process.
About what lots of feedstock requires environment variable and then
Well, you can do it in the dashboard, but it does do a whole redeploy because it's tied intimately to the container, right? So, let's see. So, we're almost out of time. So we already saw the dashboards. We already saw how it's SSH. Further documentation is available to you guys. I encourage you to look into it and to start tinkering with this and having fun and asking in our Slack channels, Kubernetes, cluster management, and productivity. And follow-up things to be worked on is login implementations. We're working now on standardizing the logging which is just going to be an image that you attach and takes care of everything, and you don't have to be doing any specific sumo logic agent or none of that sort. I know there's a few guys working on that. The production environment is a follow-up. The scaling, something I didn't touch. Workers and scheduled jobs, we didn't touch here, and specifically migration plans that we're currently working on. Because this is going to imply that you're going to have to migrate away from a service in Heroku if you have it, like a database or a cache, so on and so forth. So, any questions?
So we're not currently ready to migrate things to Docker. We're waiting on that.
I think the manifest is working. I didn't cover it here. That's what I kind of meant. But I haven't tried it yet, so I guess we need to start trying them so we can figure out what needs to be added, modified, and so on and so forth. But
Figure out databases and caches and all that.
yeah, I mean, unavoidably, you're gonna have to add chores to do a migration of the database, and then switch it over the DNSs and the environment variables and so on. I think that the important thing is that we get most of the stuff in QA first, let it simmer for a while until we figure out everything, and by that time, I think we're gonna have enough information to be able to go to production with this. Okay. Any other questions? Any thoughts? You guys like it?
Yeah, it's great.
You not like it?
Does the structure that you mentioned in the beginning with the master nodes and their associated, I guess we call them clusters or something, does that ever come up when you're debugging issues, or is that just totally abstracted away?
That's totally abstracted away. That we don't have to worry about. That's like this is provided to you, and you got to focus on ExoHelm, doing your deployments and managing them. But I'm sure there's going to be bumps along the road. So the more we use it, the more we discover what those bumps are. Bump. Okay, guys, thank you so much.